All right, so evaluating a log is the same as evaluating an exponential expression. So in number one, it's asking you 5 to what power is 25? So the answer is 2. 6 to what power is 6? So the answer is 1. And 7 to what power is 49? So the answer is 2. So do you want to go through the answers now to the rest of them? So the base of the log is always the base of your exponential expression. So 3 to what power is 27? So what did you guys say for number 4? 3, yep. Number 5 was 2, yep. 8 squared is 64. Number 6, 1, because 11 to the first is 11. What about number 7? Yep, 2 to the fifth is 32. And if you don't know that one in your head, count it up on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That was 5 2s right there. We already did number 8, that it was -1. What'd you say for number 9? 2, because 9 squared is 81. Number 10? 0, right? Anything to the 0 power is 1. So anytime you have a log of 1, no matter what the base is, you're going to get 0. That brings up for our graphs, it's going to be our x-intercept this time. When you plug in 1 for x, you're always going to get 0 for y. It's the inverse of the exponential graph, so that should kind of make sense. What'd you say for number 11? 2 cubed is 8, so 3. Number 12? 2, because 4 squared is 16. Number 13, we said that we have to write in a base of 10. It's kind of like when you take the square root of a number, do you have to write that there's a little 2 right there? No, you know that that's a square root. So I don't have to write the square root of 16. But if I wanted to do like the cube root of 27, I have to write the 3 there. That's called the index. So it's kind of like that for logs. If there's nothing there, you know it's a common log with a base of 10. So number 13 should have been 2 as your answer, right? 10 squared is 100. What about 14? 5 cubed, yep, so 3. Number 15, 4, because 2 to the 4th is 16. Are you getting most of these? Kind of makes sense, the pattern. Number 16, 3 squared is 9. 17, 10 cubed is 1,000, right? You count the number of zeros, and that's the power of 10. 18 is -1 this time because you're taking the reciprocal. So number 19 is kind of the same thing. You're taking the reciprocal, but you're also squaring the number. So did you get -2 for that one? Okay. And then 20 again is kind of like number 10, right? Anything to the 0 power is 1. So you just evaluated logs, right? And you've never probably